1, 2, buckle my shoes. 3, 4, shut the door. 5, 6, I love physics. 7 and 8, Andre's late. 9, 10, let's learn again.
Welcome! Today we're going to delve into relative velocity. But before we start, let's first differentiate between the two important concepts, speed and velocity.
Speed is the ratio of distance to the time in which the distance was covered, while velocity adds direction to the equation. Remember that velocity is a vector quantity. The relative velocity is defined as the velocity of an object with respect to a frame of reference. Now, let's meet our friend, Andre, and witness how relative velocity plays a role in his daily commute to school.
Andre commutes to school every day by riding the metro. Every day during his commute, he uses the moving sidewalk at the metro station. This moving sidewalk is 50.0 meters long and moves at 1.25 meters per second.
Now, on the first day, Andre isn't in such a hurry, so he decides to take it slow and stand still on the moving sidewalk. So how long would it take Andre to reach the end of the moving sidewalk? First, we know that the moving sidewalk is 50.0 meters long and is moving at 1.25 meters per second. We also know that Andre is standing still, so he is not moving relative to the sidewalk. Next, we need to manipulate the formula in a way where the distance divided by the velocity equals the time it takes for Andre to reach the end of the moving sidewalk. Therefore, 50.0 meters divided by 1.25 meters per second will give us 40 seconds as the time Andre takes to reach the end of the moving sidewalk.
On the second day, Andre is in a hurry and doesn't want to be late because it's exam week, so he decides to walk 1.5 meters per second relative to the moving sidewalk in the same direction. How long would Andre take to reach the end of the moving sidewalk this time? First, we already know the distance and the velocity of the moving sidewalk. However, this time Andre is moving at a rate of 1.5 meters per second relative to the sidewalk, so we will add Andre's velocity with the sidewalk's velocity. And using the same formula, we divide 50.0 meters with the sum of 1.25 and 1.5 meters per second, which will give us 18.18 seconds. So it will take Andre 18.18 seconds to reach the end of the moving sidewalk if he's walking along the sidewalk.
On the third day, Andre didn't get enough sleep the night before, so he went on the other sidewalk that moves 1.25 meters per second, walking at a rate of 1.0 meters per second relative to it in the opposite direction. How long would Andre take to reach the end of the moving sidewalk? This time, we will subtract 1.25 meters per second by 1.0 meters per second since Andre is walking at the opposite direction. So 50.0 meters divided by 1.25 meters per second minus 1.0 meters per second equals to 200 seconds. Thus, it would take Andre a very long time to reach the other end of the moving sidewalk.
Eventually, Andre realizes that he rode the wrong sidewalk and quickly rushes to the correct sidewalk. Unfortunately, he missed the train and had to wait a long time for the next one.
Just missed the bus. I missed the bus.
In the end, he arrived in class at 9 o'clock, and Atlantis all clapped as if he broke a world record for the latest person to arrive to class.
That is all about relative velocity. Thank you for listening and remember to always use the correct sidewalk when commuting to school.